Right. Well, let's get this show on the road. It's really weird not being able to see the audience, but that's the world we live in. Hey, everybody. My name is Salem. My pronouns are he, him, and I'm an engineer on the web platform team. And I'm super excited for today's talk, and I'm really glad that so many people have tuned in to listen. Before I kick things off, I have two pieces of logistics that I need to take care of. Number one, if you want to talk about this chat in real time as it's happening, join the TypeScript channel on Slack. I'll also be keeping an eye on things in there, so if anything goes wrong or goes right and you want to say something about it, I'll hopefully see it. And if I don't, please feel free to @me. My handle is just Salem on Slack. And number two, there is an MC for this talk. So if you have any questions, you can ask them at go/TypeScript-MC. And we'll be saving some time at the end for questions and answers. So, add them whenever, vote on questions as the talk goes on. We'll make sure to get to them at the end. And I'd really quickly, before we start, like to thank a few people for helping me put this event together. Huge thanks to Katie Seiler-Miller, as always, for her excellent speaking advice, to Rebecca Slider to help me brainstorm how to do put together a talk for Internet Times. For Natalia, huge thanks to her for helping me coordinate, figure out logistics, send emails, figure out paperwork, talk to HR, all that fun stuff. And to Arlie and Dan for making this happen, and especially for making it happen during Product Infrastructure Week. And extremely, of course, to Siwan Lo for proposing this idea in the first place, for putting me in touch with Dan, and for being really encouraging about getting this talk to happen at Etsy as we're rolling out TypeScript. Enough of that. I don't want to talk too much because we only have an hour, and there's a lot of really cool stuff for y'all to hear. So I'd like to introduce our speaker today, Dan Vanderkam, who will be giving today's talk. He's the author of O'Reilly's Effective TypeScript, which is officially available in Polish. He's a principal engineer at Sidewalk Labs. He's previously worked on open source genome visualizations at Mount Sinai's ICANN School of Medicine and on search features used by billions of users at Google. If you Google population of France or sunset in NYC, you'll be seeing just a little bit of his work there. He has a long history of working on open source projects, including the popular Digraphs library and Source Map Explorer, a tool for visualizing JavaScript source code. He's also the co-founder of NYC's TypeScript meetup, and he blogs at effectivelytypescript.com. With that, give it up for Dan Vanderkam. I can hear your applause over the internet, I'm sure.
All right, thank you, Salem. Yeah, so I'm Dan, and I'm going to talk to you a little bit today about what is TypeScript and how you can use it effectively. So if if this seems interesting to you and you want to hear more, I would highly recommend getting a copy of the book. So yeah, Salem mentioned a little bit about myself. So just to add some pictures to that, here I used to work at Google. I worked on some of these interactive search features. So as you can imagine, these all used various forms of JavaScript. I currently am at Sidewalk Labs, which is part of the broader Alphabet family. So we do a lot of work around trying to use computers to help design neighborhoods and cities in such a way that you can maximize things like both the number of apartment units you put in, but also do that without harming things like shadows falling on the ground, like sunlight in parks, that sort of thing. And so there's also a lot of visualization that goes on there. I've also done a lot of side projects over the years. So maybe some of you guys have seen this old NYC. So this was a project I did with the New York Public Library that geotagged historic photos. So I couldn't quite find one of the Etsy office, but this blue dot is maybe close. So, this is what Dumbo looked like in 1934. Same old cobblestone streets, nothing's changed. So you can check that out if you want to see some historic photos. So a little bit about effective books. So there's a whole sort of loose series of books that follow this style. So they're all effective programming language, and then some large number of specific ways to improve your programs. And so when I first started working at Google years ago, they actually gave a copy of Effective C++ to everyone who joined, which sounds like a great book deal. I would love to get that. But it actually worked out really well for me because I thought it was a pretty different type of programming book than I'd ever read before. I think a lot of books about programming languages try to teach you programming from the bottom up in that language, and don't really assume any prior experience. But that's very much not what the effective books do. The effective books assume that you already know the language. They assume that you already know a little bit of C++. And then they try to teach you about usage of that language. So rather than how do you do something, what are the 8 ways to do something in C++, they'll tell you which of those 8 you should do and why. And so they guide you towards using the language more effectively. So I had a great experience of learning, getting better at C++ by reading Effective C++, and then later on I had similar experiences with JavaScript and Java. I felt like I could read the book, and then suddenly I could recognize some of those patterns in my own code, or when I was reviewing other people's code, I could understand how they were solving problems and how they maybe should be solving problems instead. So I think for effective TypeScript, if you know JavaScript and you've maybe dabbled in TypeScript, but you want to feel like you're more of an expert in it, you want to feel like you know what's really going on, I think an effective book is a really good choice. I've always been curious about effective Perl. I'm not sure I think that might be an oxymoron, but yeah, when I started working with TypeScript, I wanted to read an effective TypeScript book, and there wasn't one. And then sort of over time, I realized that, well, maybe I should just write it. So that's what I did. Okay, let's talk a little bit about TypeScript. So you guys are sort of adopting TypeScript as a company, as I've heard. So I think it's a great choice. So I'll explain to you why I think you've made a great choice. So one reason is that TypeScript is really seeing rapid adoption right now. So this is from a survey that GitHub puts out every year. I think it's based on number of contributors to repos of different languages. So I think the rise of TypeScript is really one of the dominant features in this chart. It's interesting that it passed C# this past year, because as C# users might know, they're actually created by the same guy, Anders Heilsberg, who works at Microsoft. So I'm sure he has mixed feelings about seeing one of his languages pass one of his other languages. Probably less mixed feelings about PHP. Another good reason to use TypeScript is, this is one of my favorite tweets. Everyone has had some issues with JavaScript not really making sense, and so maybe TypeScript can help Ben figure out what this refers to. So just sort of trying to think about, like, what are the wins of static type systems. We can sort of start to go through those. So I think maybe the most famous reason to use a static type system is type safety, right? You want to be able to catch errors before they make it out into your production site. There have been some studies, like I think Airbnb put out one in the last year or two, looking at their postmortems, and they found that something like a third of their postmortems, the underlying bugs could have been caught using TypeScript. So there are a lot of errors that you can catch before you run your code. But then there's some other wins as well. So I think using a static type system really improves readability. And by that, I mean readability for your coworkers, right? So if you write a function and you declare that the parameters are expected to be of a certain type, that's telling something to the compiler, sure, but that's also telling something to your coworkers who are reading your code. So there's this old Fred Brooks quote. I think the language is a little dated, but the gist is that if you show him your code but not your data structures, then he'll be confused. But the other way around, if you show him your data structures, the code will be pretty clear. And then there's tooling, which I sort of think of as readability for machines. So if you use any sort of editor, it can hook into the TypeScript language service, which is a separate binary that runs over your code and analyzes it and provides things like autocomplete and refactoring. And I think that actually winds up being one of the biggest wins of using TypeScript, is that you suddenly get all these really nice pieces of tooling, like renaming symbols globally across your code base, or changing some types in one place and seeing all the places that has ramifications. And so TypeScript isn't just about type safety. It's also about improving developer experience across the board. And then sort of traditionally, there's runtime performance is another good reason to use type systems, that if the compiler can figure out in advance what the type of a symbol is, it can generate more efficient code. But for reasons that we'll talk about, that's actually not relevant to TypeScript. So runtime performance is not a reason to use TypeScript. So a little more about effective stylebooks. So the items, I think it's 62 specific items in effective TypeScript. So they sort of boil down into these 3 categories. So things you should do, things you should avoid doing, and mental models that are helpful to build. So I think one of the ways that a programming language can be frustrating or can lead to confusion is if you have the wrong mental model, because then you can't really predict what's going to happen or reason about why you're running into errors. And so I think it's really important to build strong and correct mental models of how a language works. And so some of the items in the book help you do that. So I figured I'd go through and present a couple of different items from the book to give you a flavor for it and sort of talk a little more about TypeScript. So the very first item in the book is understand the relationship between TypeScript and JavaScript. So one of the interesting things about TypeScript is that what is TypeScript is maybe a question that people ask more than they do with other languages. And it's actually a little confusing to explain. So you might hear this saying that TypeScript is a superset of JavaScript. And when I first started using TypeScript, I found that phrase pretty confusing until I realized it's really just a statement about syntax. So syntactically speaking, any JavaScript program is a TypeScript program. It doesn't mean that it passes the type checker. It just means that it is a TypeScript program. So if you ever hear people say that TypeScript isn't JavaScript, that is like mathematically not true. But maybe a slightly more interesting variation is TypeScript is a typed superset of JavaScript. So I think when people talk about TypeScript programs, they usually mean TypeScript programs that pass the type checker. So not every JavaScript program will pass the TypeScript type checker, as we'll see. So this is, if that statement that TypeScript is a superset of JavaScript feels wrong to you, maybe you're thinking of this bubble that is TypeScript programs that pass the type checker. So let's hop over into the TypeScript playground. So if you haven't seen the TypeScript playground, it's pretty great. TypeScript is TypeScript is written in TypeScript, which is sort of a little head scratchy, but one of the things that means is that it runs great inside the web browser. And so the TypeScript playground, what it does is it gives you an interactive TypeScript editor online. And so it's a pretty useful way to just quickly experiment with things and share links. And I actually think it's a really helpful tool for understanding what TypeScript is, because so TypeScript at its core kind of does 2 things. One of these it's more famous for, which is type checking, but the other is just as important. So TypeScript, the other thing that TypeScript does is it generates JavaScript. So TypeScript takes TypeScript and produces JavaScript. And what I love about the TypeScript playground is that it shows you that process. So on the left, we have TypeScript, and on the right, we have JavaScript. And maybe an interesting thing to notice here is that they're almost identical to each other. I think except for white space and comments, they're like literally identical to each other. So that's sort of TypeScript is a superset of JavaScript manifesting itself. And what's sort of interesting is that, so I don't know, maybe it's let's write out a function. So like we could have text, and we'll convert that to a number. And so you can see that that gets converted to JavaScript over here. The interesting bit is that the type annotation gets stripped off. So the conversion is pretty straightforward. But what's interesting is that TypeScript is a superset of the latest version of JavaScript, and it can produce JavaScript targeting any version. So if right now I'm targeting ES 2017, but if I go down to ES 5, let's say, then you can start to see some changes. So the let and the const have become var, and this for of loop, I think that was an ES6 edition. So that got rewritten as an older style for loop. And then if you start to use some newer features, like let me go back to ES 2017. So let's make this function async. So ES 2017 supports async functions, so that just gets converted, in the straightforward way. Maybe let's go to ES 2015, aka ES6. So now this is looking a little crazier. So ES 2015, ES6 didn't have support for async and await, so TypeScript has to emit some helper code, and then it uses it down here. So that's interesting. And then if we go all the way down to ES5, like now things are really crazy. ES5, I think the ES6 version rewrites the promise of the async function as a generator, but then ES5 doesn't have support for generators, so it needs to emit some code that helps with generators, and I think it's rewriting them as like a finite state machine. I've never really tried to figure out what was going on here, but kind of, I guess the point of all this is that whenever you run TypeScript, what's actually happening is that your TypeScript is getting converted to JavaScript, and then the JavaScript is getting run. And most of the time that you're working in TypeScript, you don't look at the generated JavaScript. But I think for understanding how your TypeScript will behave at runtime, it's really helpful to just have in mind that this JavaScript exists, and that's the thing that actually gets run. In particular, what we saw earlier was that type annotations got stripped out, and that's kind of an important part of this conversion, which I'll talk about a little bit more in a minute. So the other thing that TypeScript does, and that it's much more famous for, is static type analysis. So TypeScript, what that means is TypeScript tries to go through and find parts of your code that will fail at runtime, that will throw exceptions at runtime, and surface those without having to run your code. So in this case, I'm trying to call the toUpperCase function on city, which is a string, and TypeScript correctly points out that it should be a capital C. So if I change that, the error will go away. But if so that's one type of error that TypeScript will catch. If I run this code, something that will happen is we'll see that it logs undefined 3 times because here I've written capital. I have a list of states and their capitals. I spelled capital with an A, but when I'm logging it, I spelled it with an O. And so this is kind of another category of errors that TypeScript will try to catch for you, which is situations where you did something that's legal in JavaScript, but probably not what you intended, right? And so this is a case where it doesn't throw an exception at runtime, but TypeScript is still able to flag with some confidence that this is actually a mistake. And so I should replace this with an A. So another way you can get at this is we can define a type. So I can create a state type that has a capital with a string. And I can say that this is expected to be an array of states. And what's interesting about that is now if I misspell capital here, TypeScript actually knows that that was what the mistake is. So by adding the type annotation, you're telling TypeScript what your intention was, what your intent was with this. And going back and looking at the generated JavaScript, what's interesting here is this type that I've defined, state. It doesn't appear in the generated JavaScript. So part of generating JavaScript from TypeScript is stripping out all the types. if you ever worked in Java before, this is sort of familiar from how Java implements generics. So in Java, you write out list of string, but then when your code runs, it's just list. It's forgotten that it's a list of strings. So that's called erasure. And I think that's a useful way to think about types in TypeScript is literally every type in TypeScript is erased. It just doesn't exist at runtime. And so if you want to query a TypeScript type at runtime, that's not something you can do. You need to have some other way to reconstruct it. And we'll get into some ways that you can do that a little later in the talk. So all right, let's get to another item. So item 30 is don't repeat type information in documentation. So this is an example of something you shouldn't do. I particularly like this one because in code reviews, this is a very easy one to apply. It's just very specific. So specific and actionable. So all right, so here we have an example. I'm gonna hide the generated JavaScript. So we have this function get foreground color, and it has this big long comment in front of it. So I'll give people a second to stare at this and try to figure out what's wrong. You don't have to read too long. It's this part. So the documentation says that it returns a string, but if you look at the code, it definitely does not return a string. And so I think this is one of the real problems with putting type information in the documentation is it tends to get out of sync with reality. And so either the documentation is redundant with what you have said through the type system, or it disagrees. And so in this case, it disagrees. So it's not really adding any value. If we mouse over get foreground color, you can see that TypeScript has inferred the return type as this RGB object. So that's I'm going to assume that that's what we intended. So let's remove the returns a string because that's wrong with the foreground color. I think that's pretty obvious from the function name get foreground color. There's other sorts of things that are type information in here. So it takes 0 or 1 arguments. Well, that's kind of clear from the declaration, right? We declared that page was an optional parameter, so I think we can remove that. It's also kind of wordy. So the comment is longer than the function, which is usually not a good sign. So I don't know. I might just rewrite this as like returns the foreground color for a page or an app-wide default, something like that. And if you have a short comment, there's like a compact form of JS.comments that you can use. Incidentally, the reason to use JS.comments with the /* is that in your editor, they'll show up on the usage. So that's kind of a nice thing to take advantage of. If you wanted to include information about the return type, I think the right way to do that is to just define the type and then add an annotation. And this way, if you don't do that, so this is better than putting the returns color in the documentation, because this way TypeScript will actually enforce that that's what you do, right? So if you actually return an H, you'll get an error, right? And so it both communicates what it returns to the human reading the code, and it enforces that remains true. So here's another example of type information in the documentation. Either A will be set or B will be set, but not both. I'm maybe not going to dive into exactly how you represent that in the type system, but you can do that. Here's another interesting example of type information in the documentation. So here we have this sort numerically function, sorts the strings by numeric value, includes an example. That's always a nice thing in the comments. And it says does not modify nums. So anyone who's used the JavaScript sort function, it's classic trap you can fall into. It definitely modifies nums. So the way you can enforce this with TypeScript is you can say that it's a read-only string instead of a string array. And now TypeScript actually flags that you can't call sort on a read-only array because it would mutate the array. And so you need some way to fix that. So I'd say that does not modify nums is now redundant with the type, so we can remove it. And we need to fix the error now. So I think probably the easiest is just to make a copy of the array. And what's worth noting here is changing between string and read-only string. That doesn't appear in the generated JavaScript at all, right? That's purely a type system construct. But it does offer the reader some assurance that you don't modify the nums array, and it enforces that as well. So don't repeat type information in the documentation. OK, so item 7, think of types as sets of values. So this one is a little more theoretical. So let's jump back into the playground. So I think people talk about types a lot, but we often don't really define what a type is, which is sort of interesting. So I think in TypeScript, probably the best way to think about what a type is as a set of possible values for a symbol. So JavaScript is famously very permissive about it, what it lets you do. So we can create a variable called x, we can assign it to a number, and then the very next line we can assign a string to it. And that's fine in JavaScript. It has no problem with a symbol changing its type from line to line. But that tends to be confusing, and TypeScript does not allow that. So in this case, when we first assign the symbol, assign 10 to x, TypeScript infers that x is a number. And so we can add that annotation explicitly just if we want. And then the next line, when we try to assign a string to it, it complains that type string is not assignable to type number. So I think this is a useful thing to have in mind, is that in TypeScript, a symbol can change its value. That's no problem, but it can't generally change its type. So whereas that is possible in JavaScript. So what if you wanted to allow it to be assigned a string? Well, then, remember that it's a set of possible values, so we need to expand the set of possible values. So one way we can make this work is by saying that x can be a number or it can be a string. So you read this as or in TypeScript, or you could talk about it as a union type. And now x can be a number or a string, and so assigning to the string 10 to it is just fine. But if we tried to assign it to a regex, that would be an error, right? Because that's not a string or a number. And so thinking about types as sets, I think one of the, types like number and string are pretty familiar from other programming languages, but TypeScript lets you get a lot more granular than that. So you can actually define a type as a union of specific values. So in this case, we can define a type ABC as it can be either the string A, or it can be the string B, or it can be the string C. And that really explicitly defines the set of possible values that this a symbol with this type can take on. And so you can see that here, where we, instead of declaring that A is a string, we've declared that it's an ABC, which is a narrower type. And so we can assign it to A, that's fine, that's part of the type. We can assign it to B, that's fine, that's part of the type. But if we try to assign it to D, it will say that D is not assignable to type ABC, which is right, because it's not one of these elements. If we added D, then it would be fine. But also if we said this was a string, well, we've expanded the set of possible values. So it really is, it constrains the set of values that a symbol can take on. So if this word assignable appears a lot in TypeScript. So let's talk about that a little bit. I think when you see assignable and you're thinking about types as sets, really the way to read that is a subset of. So let's say we have a type AB that could be either A or B. We have some variable that is of that type. Then can we assign AB to A? Well, A or B, 2 elements, that is a subset of ABC, which could be these 3 elements. And so this is allowed. But if we change this to D, well, suddenly it's not a subset of ABC, right? And so it's not allowed. So it's interesting that types in TypeScript are rarely compared for equality. You rarely check that 2 types are equally to each other. You usually check that they're assignable to each other. And I think it's helpful to read that as a subset of. So another interesting thing about TypeScript is that in most languages with a type system, a type or a symbol, a variable has a specific type and it keeps that type. But in TypeScript, types or symbols actually have a type at a location. So it's a little more complicated than that. And there are a few cases where this comes up. So here we're looking for an element in the DOM with the ID of my L. And so it can come back as either an HTML element or null. And so when we try to read its text content, TypeScript's going to complain that the object might be null, which, fair enough, it could be null. So the usual way to solve this problem is you throw an if statement around it. And this is pretty interesting because so here, L has a type of HTML element or null. Here could be HTML element or null. But here, it's specifically an HTML element because through this if statement, we've eliminated the possibility that L could be null. And so it stands to reason that if we add the else branch, in this case, L has to be null, right? Because that's the only other possibility. TypeScript is quite good at this sort of refinement, or narrowing is another name that's used for this. So this is a classic JavaScript gotcha. So if you try to check whether it's returned an HTML element this way, you still get an error because it's saying that HTML element, or it still could be null. And you look at that for a minute and you puzzle over it, and then you remember that this is one of the famous bugs in JavaScript, is that type of null is object. And so this doesn't actually work. So you actually need to check for null. So that's a pattern that comes up pretty often in TypeScript. So it's a good one to be aware of. So another case that I think thinking of types as sets helps is for thinking about interfaces extending each other. So here we have a student where the name could be string or null. And you can define this other interface, student, which extends nully student. So this is sort of a way of doing subtyping in TypeScript. And we've redeclared name as just being a string. And I think you should read extends as subset of, which string is a subset of string or null. And so this is okay. Whereas if we define name as string or date, well, we get this assignability error. So that's a thing you can do that doesn't necessarily have a clear analog in other languages. So I guess just another way of putting this is the subtype relationship, or like the relationship between types, is a little more interesting in TypeScript than maybe you're used to. So you can think about subtypes in other languages. So here we have 3 types of vector that form kind of a natural subtyping hierarchy. So on the left here, we have that hierarchy drawn as a tree. But on the right is, if you think of them as sets of values, then you can kind of think about them as overlapping sets, that every vector 3 is a vector 2 and every vector 2 is a vector 1. And what's interesting about TypeScript is it's a structural type system. So you don't actually need to declare these relationships for them to be true. And I think that when you rewrite these vector types without extends, it's much clearer that this set relationship holds than it is that this hierarchical relationship holds. And you can also get these situations where you can have two types in TypeScript that overlap but aren't equal to each other, which is not, sorry, I should say where neither is a subset of the other, a subtype of the other, which is not a thing that can happen in languages like C# or Java. So just something to be aware of, that the types in TypeScript are actually quite rich and expressive. Okay, so here's another fun one. This is something you should do. So this is prefer types that represent valid states. So so let's say that we have some state and we're going to render a page based on that. So you can imagine this is something like React. So here's our state object, and so we're going to render the current page and the page text, but actually like the page might be loading, it might be an error. So maybe we should check if like state.error, return error, and then maybe we could include the error. Or if state.is loading, maybe we should return loading. And so I guess the problem with this is that what if like there was an error, or if both error and is loading are set, like how do we know which one is correct, right? Is it that there was an error and now we're loading the new version of the page, or was it the other way around? And I think this structure can also lead to sort of like subtle race conditions where you try to load a new page, so you update current page and set is loading, but then like a previous request, the response comes in and it sets page text, and then like the two of them get out of sync with each other. So I think this state has an issue, which is that it allows combinations of values that it really shouldn't. So let's look at a slightly different way of defining that state, which is a little more elaborate, but I think is ultimately leads to better code. So so here we're defining different an explicit type for each state that a request can be in. So the request could be pending if it's loading, it could be an error, or it could be a success, in which case it has some text. And then the overall state is one of those three types, right? So every request is either pending or error or okay. And then we have a current page for our overall state, and we have a mapping of page to request state. So we're keeping track of each request. So that race condition we were thinking about earlier, where you are waiting for a request to come in, and then you change the page, and then the request comes in and you overwrite the content for the wrong page, like that can't really happen because every request has a correct slot to go into. So let's see what this looks like if we try to use it. So first of all, we can't read page text off of state because we don't actually know that. Well, actually, I guess I should need to pull some properties off. So page, and let's pull off requests, and then maybe we can say like request is requests current page. So, and then this should be request. So we're still going to get an error, which is that pending doesn't have a page text, error doesn't have a page text. So we actually need to check what the type of, or what state the request is in. So if it's okay, well then we can render this, right? So now that's not an error. But now we can also check the other states, right? So if it's loading, or what was it? Pending. That's an example of TypeScript giving you nice autocomplete. So then, yeah, maybe we'll just return loading. And what's the other possibility if request.state is, well, there you go, error. Then maybe we return that there's an error. So yeah, so now we know that it has an error because we've refined the state. So this this type has forced us to actually like check what the state of the request is in before we render it, and it enforces that each request can only be in a single state at a given time, which I think leads to writing much more, or it helps you write much more correct code. The code to change pages is also kind of interesting. If you're interested in that, I'd encourage you to check out this example in the book. And then I guess we got a few minutes, so I'll maybe just show you this one really quickly. So I think you can often feel like you're fighting the type checker if it's just frustrating that TypeScript doesn't understand you. So here we have a function that takes it tries to issue a greeting, and it takes this birth date that could be a date or a null, and then depending on whether birth date is set, we'll calculate your age in milliseconds, so that can be a number or a null, and then we'll add some more information to the greeting if we have your birth date. And TypeScript's complaining that age milliseconds could possibly be null, which is wrong. You can go through and reason out that like age milliseconds will only be null if birth date is null. So we've excluded that possibility through this check. But TypeScript just knows that age milliseconds is number or null. It doesn't really know about that relationship, and so it's not able to follow along. So I guess kind of if you're getting frustrated by this, there's a few ways you can fix the error. So kind of the most brute force-ish is if TypeScript thinks that it's number or null, you can just add an exclamation point, and now it will think it's not null. This is a type level exclamation point, so it doesn't appear over here in the JavaScript. Or even crazier is you can just like ts ignore. I think will make it go away. But you're kind of losing the advantages of using the type system that way. So like with this, we can construct that reasoning that it's not null, but if we refactor this code at some point, that reasoning might no longer apply, and TypeScript won't be able to check it for us. So this is usually not a good way to do it. So some other ways you could solve this problem, well, right now we with this if statement, outside of it, birth date is date or null. Inside of it, birth date is date. So we refine birth date, but maybe we should just refine on age milliseconds instead. And if you want to be picky, maybe we should just check if it's null. You could be 0 milliseconds old. So that's one way to solve it. Another way is why create this separate variable outside of the if statement, right? So we could move the check here, and we could move this age milliseconds variable in here, and now we actually don't need the check, right? Because birth date is non-null, and so we can just append the greeting that way. So that's another way to solve the problem, is restructuring your code a little bit so that TypeScript can follow along. And then I guess one sort of final way you could do this is sort of the core issue here is that the nullness of birth date and age milliseconds are tied to each other. So we could make that more explicit in the type system. So so we could create this object that has a birth date field and an age milliseconds field, and then this way we'll either have both of those or neither. And so now we can just check age here, and then we know that birth date is not null, and we know that age milliseconds is not null. So I think that's a little overkill here, but it's sort of an interesting approach that sometimes makes sense in a slightly more elaborate, fancy situation. So yeah, that's kind of all the material I had. So I guess just some things to remember. So TypeScript types go away at runtime. Don't forget that. The thing you're running is JavaScript. It's not TypeScript. When you're when you're transitioning to TypeScript, just remember that the developer experience, I think, is as a big a win as the type safety. I think people tend to focus a lot on the type safety, but I think developer experience is just as important. Try not to repeat type information in the documentation. If you catch yourself doing it, think about how you could maybe represent that in the type system. Think about types as sets of values, and when you see assignable, read that as subset of, or extends is also subset. And sort of think about your types before you write your code, right? That good types tend to lead to good code, and vice versa. That if you find yourself fighting with the type checker, that's usually not a winning battle. So think about how you can maybe restructure your types or restructure your control flow so that the type checker is able to follow along a little bit better. Yeah, thanks for listening. Feel free to reach out to me. I definitely encourage everyone to, if you thought this was interesting and you want to hear more, definitely buy a copy of the book, or if you have friends at other companies who you think might enjoy a talk on TypeScript, I'm always looking to do more talks like this. And yeah, all my contact info is there, and I blog over at effectivetypescript.com. So thank you. And I think with that, maybe we could take some questions.
First of all, thank you so much for this talk. This is fantastic. I learned so much, and I didn't even have to move. I just sat here and stared and listened. And I have to tell you, there's this TypeScript channel that's been pretty loud the whole time. People are really enjoying this talk. So you just have to assume that there's a lot of people out there cheering, because this is the only feedback you're going to get. I'm sorry. I took some fun shots, so maybe I'll share.
That's great to hear. Yeah, I think TypeScript is a really fun language. It's I like working in it a lot, and I guess maybe another thing to mention is that it's still a pretty rapidly evolving language. Like they do new releases of it 4 times a year, and they often include pretty exciting new features. So like the latest TypeScript 4.1 release had some pretty major new features in it that I'm pretty excited about, and so it's yeah, it's a fun ecosystem to be in. There's a lot of growth right now.
Well, we do have a few questions they're slowly starting to trickle in. So as they come in, I will read them to you. If anybody is listening and doesn't know where to ask questions, again, that's go/TypeScript-MC. First question comes from Sherman, and they ask, do you have any tips on working with untyped third-party libraries, short of having to type it yourself? And also, thanks for the talk. I learned a few cool tips.
Cool. Yeah, that's a great question. So I think third-party type declarations are, when they work well, they're awesome. And when they don't work well, they are like the bane of your existence. So yeah, I think one of the lessons that the book tries to sort of convey is that good accurate types are the best, but in some ways, like incorrect types can be worse than no types at all, because that is a great way to get yourself in a position where you're fighting with the type checker. So yeah, if you're running into issues with incorrect types or missing types, I feel your pain for sure. But one thing you can do is there's sort of a progression of typing a third-party library that looks a little bit like converting your own code. So you can start by introducing your own type declaration file that just has like a declare module line in it, and that assigns an any type to the entire module. I guess we didn't talk about any in this talk, but that's another thing to avoid if you can. But then, if you that gets rid of the errors, but doesn't give you any type safety. And so then you can start adding in methods, or you can add in more declarations to that file as you need them. And eventually, if that grows anywhere close to a complete type declaration, then you should probably go contribute it back to definitely typed, which is the repository of third-party type definitions.
Thank you. Next question is anonymous, and it says, aside from the book, what are some other resources for learning TypeScript that you would recommend?
Yeah, so Anders Heilsberg, the guy who created TypeScript, he gives a talk at the TypeScript conference every year. He probably does more versions of this talk too, but he's a really fun speaker. He's sort of this jolly old Danish man, and so if you, I think watching his talks is a really good way to come up to speed with TypeScript. He has, sort of, I think it's a similar style to what I just did. He tries to spend a lot of time in his editor showing how things actually work. So I'd recommend checking out some of Anders' talks. There's a lot of TypeScript blogs out there. There's a TypeScript subreddit that collects a lot of the interesting blog posts about TypeScript. That's quite good. And there's a TypeScript weekly newsletter that a guy at Facebook who uses TypeScript puts together. And so you can subscribe to that, and you'll get a couple of links every week. So those are a couple of resources.
Awesome. I'm taking extremely intense notes right now, so I'm glad this is recorded too. Any tips this is from Kira, and they ask, are there any tips from moving a code base from JavaScript to TypeScript?
Oh, I'm so glad you asked. I actually have some bonus slides, so it's a good opportunity for me to go switch over to those. So, oh yeah, if anyone wants to ask about the bird on the cover, I'm happy to answer questions about that too. Yeah, so I think the main thing for converting a code base is if you want to visualize like the dependency graph of your code, sort of module by module, I think the key thing is to move up the dependency graph. So the idea is that if you have like some util library and you migrate that, then you'll fix the errors in the util module itself. And then when you start migrating the code that depends on that util module, you'll be able to fix the errors in your application code. But if you do it the other way around, like if you migrate your application code, you'll fix some errors there. But then when you migrate the utils library, you'll have to go back and fix your application code again because the types will have gotten better. And so I think it tends to work better if you can just move up the dependency graph, because you'll migrate a module once and you'll never have to migrate it again. So in practice, there's the question about third-party code beforehand. That usually is the place to start. So just adding in @types dependencies, and then migrating sort of your core libraries is usually the next thing to go, because that makes migrating your application code easier. There's also TypeScript we didn't really talk about this, but TypeScript has a lot of different settings that you can turn on for whether every symbol has to have a type, whether you want to track null values and undefined values. And so if you have a big messy code base, then maybe you don't want to turn those on at first, and that can make migrating easier. But it can also mask a lot of errors, so you definitely do want to get the stricter settings on eventually if you can. But yeah, migrating up your dependency graph is sort of my main bit of advice. Also, I think as you migrate code, you'll probably discover a lot of weird things, or like just stuff that doesn't really make sense. Like my favorite example, it's actually from this digraphs library. With JavaScript, you don't have to declare all the member variables of a class. You can just assign to them. But then with TypeScript, you do have to declare them. And so when I migrated the digraph class, sort of the core class of the library, I discovered that I think it had something like 35 or 40 member variables on it. It was just some absurd number of member variables. And you would never design it that way, but I think TypeScript has a way of forcing you to see your designs sometimes for the first time, and you might not like what you see. But I think when you're migrating, the key thing is just when you see weird stuff like that, just note it down, like write it down somewhere, but don't change it yet. You kind of want to separate the migration and the refactoring to clean up your mess. Maybe just like throw in a as any and a to do, or like another good trick is you can define a type alias for any. So like this is something that people do when they update TypeScript versions. So TypeScript 4.1 came out a few weeks ago, so I created a any for TS41 type alias and just use that in a few places, and then I I went in and fixed them one by one because defining the type alias made it easier to find those. So yeah, that's some advice on how to migrate code.
That's fantastic. All of these little nuggets are extremely useful. I'm like really glad to have heard them now and not 3 months from now. Of course, as soon as you mentioned it, everybody wants to know about the bird on the cover.
Oh yeah, so glad everyone asked. So yeah, let me present that again. Okay, so yes, so the bird on the cover is the red-billed oxpecker. So I was thinking that I wanted something vaguely JavaScript themed. So JavaScript, the definitive guide, has the rhino on the cover, and TypeScript is built. It works on top of JavaScript, much as the red-billed oxpecker sits on top of the African rhinoceros. So I thought that was appropriate. But then after I thought of that, I found out it's even better. So how does the red-billed oxpecker survive? Well, it eats the bugs off the rhino. Much as TypeScript helps you find the bugs in your JavaScript. So TypeScript is your little friendly bird friend. Helping you pick the bugs off your JavaScript. So that's kind of how I wound up with that cover.
I think about a third of Etsy engineers are screaming right now. There's a few more questions. I want to try to get through them. I know we only have a few minutes left here. But first and foremost, does TypeScript have support for pattern matching on types?
Yeah, so it's a good question. I think the way you do that in TypeScript is generally with one of those tagged unions, like we were talking about with the request state example, where you have a field like a status or type or kind, and you just you compare the value of that, and in doing that, like inside that if statement or that case branch, you've refined the type from the union type to the specific arm of that union. One of the sort of the general philosophy of TypeScript is that they add things in the type system, and they try not to add things. That manifest at runtime. And so, there are some exceptions to that, like enums are an example. I didn't talk about those, but I don't think you should use them. But so TypeScript is somewhat constrained in that it can't really add a new like runtime syntax to the language to do pattern matching. But I think there are some like TC39 proposals to do things like that. And once those make it into the standard, then TypeScript will implement them.
There was just a bunch of conversation about enums, so I think it's cool to hear somebody who knows more about it say the same things that we kind of thinking we should be doing. So that's definitely useful.
Yeah, I could give a whole talk about how confusing enums are and why you should avoid them, but maybe you should just read that item in the book.
There's two more on the docket. First one is are there any effective examples or safety precautions with using generics?
Yeah, generics are a whole other like interesting topic that I guess I didn't really get into too much here. I actually gave a talk at the TypeScript conference in 2019 about writing tests for types. The one fun thing about the TypeScript type system is someone proved that it's Turing complete, so you can do anything in the type system. But you should also if you write particularly fancy types, you should write tests for them as well. And so there's a whole bunch of different ways that you can go about doing that. One wrinkle is that I think I mentioned this, that there's not really any checks for type equality in TypeScript, which makes writing a test kind of hard if you can't test that two things are equal to each other. So sort of a trick that people sometimes do is with sets, if A is a subset of B and B is a subset of A, then they're equal to each other, which is mostly true of TypeScript types, except one of them could be any. But there's a lot of tools out there to help you test types. So I guess that would be maybe my first bit of advice is you should write tests for your type logic. I guess also maybe my 0th bit of advice is don't use generics if you can avoid it. There's a lot of times when you might think you need a generic, but you actually don't. So maybe think carefully about that. There are some times you definitely do, though.
One last question. You mentioned performance is no longer an advantage. Why is exactly again?
Exactly. Yeah, it's not that it's no longer an advantage. It never was an advantage of TypeScript. So I think the reason is that since compiling TypeScript to JavaScript just involves removing the types, TypeScript is never going to be able to be faster than the JavaScript that it converts to. So the types don't really give you any advantage since they've gone away at runtime. People are constantly asking Anders, like, are you going to support WebAssembly at some point? And I think they ask that thinking that it'll make their TypeScript faster, but I think he's just like deeply puzzled by that question and wondering like what people think TypeScript is that they might be asking that. But yeah, when I was talking about types making a language faster, I was more thinking about like C or C++, where if you know statically what the type of a symbol is, then you can generate optimized code, for whether you're doing integer comparisons or string comparisons. You don't need to figure that out at runtime like you would with JavaScript. But yeah, so TypeScript, I think it will not make your code run faster. The one performance issue is it can make your development experience slower if like the TypeScript compiler or the TypeScript server gets bogged down. But that's sort of a different issue that doesn't get passed on to your users.
Thank you. And I have one last question from me because I would like to ask this. I've been spending a lot of time trying to write types for some of these utility libraries in our code base. And it seems like there's a balance that you kind of have to strike between types that are like perfectly correct and types that are useful. In the example that you gave, being able to specify that an input to an RGB number could be any number from 1 to 255, but practically speaking, putting number there does the trick as well. Is there any tricks or tips about drawing that line somewhere?
Yeah, there's kind of an art to that. I think the saying I've heard that I like is that you should pick the most precise type that's convenient to use. So like, defining the RGB color type, you could define R as a union of like 0 or 1 or 2 or 3 or 4 all the way up to 255. But in practice, that would be really annoying to work with. And so I think really like number is probably the way to go. But generally, like I think another case where this comes up is like string. And I think often when you write string, you maybe do want something a little more precise. Like if it's just use data, some text that a user put in a form, then sure, like string makes sense. But I think there's actually a lot of places where string is not sufficiently precise, and you can catch whole classes of errors if you make it something more specific than string. But yeah, generally, I think the rule of thumb is like the most accurate, the most precise type that's convenient to work with.
I think that's all of the questions, and there's a lot of memes in this TypeScript channel, but they're not questions. So I'm going to the questions have died down for the moment. Thank you so much for giving this talk. Thanks for everybody for staying the extra 5 minutes over. Thanks again, Siwin. I don't know if you're on the stream right now, but I really owe you one. This is a great talk. And I really appreciate it. Thank you so much.
Yeah, well, thank you guys for listening. It's always fun to talk about TypeScript, and thanks for all the questions.
Actually, don't know what happens now, but I'm going to just wave at the camera and say bye and then turn it off.